Hello students, today we are going to start question number 2 of exercise 2.2, which is related to finding the quadratic polynomial when the sum and the product of its zeros are given. First part of exercise 2.2 question 2 is 1/4 and 1. First of all, we shall consider a quadratic polynomial which we have to find. Let ax plus bx plus c is required quadratic polynomial, and sum of zeros is given as 1/4, and we know that in quadratic polynomial sum of zeros is equal to minus coefficient of x over coefficient of x square, and product of zeros is equal to constant over coefficient of x square. So product of zeros is given as -1, and we know that sum of zeros minus coefficient of x over coefficient of x square and coefficient of x is b, that will be minus b over coefficient of x square is a, and that is constant over coefficient of x square is a. So minus b over a is equal to 1/4, and c over a is equal to -1. Now we shall take a is equal to 1. In all the questions you will have to put the value of a as 1. It will be easy for the question. So by putting the values we shall get minus b over 1 is equal to 1/4, and c over 1 is equal to -1, and therefore minus b is equal to 1/4 and c is equal to -1, and therefore required quadratic polynomial is ax square plus bx plus c, and we will substitute the values. We will get ax square plus bx. B is you can take b is equal to -1/4 by taking minus to this side, that will be -1/4 x, and c is -1, that is x square minus 1/4 x minus 1. And the simplest form of this polynomial will be, you will take 1/4 as common, and you will get 4x square here minus x minus 4, and and you can omit 1 by 4 from the extreme outside. You will get 4x square minus x minus 4. This is the answer. That is x square minus 1 by 4 x minus 1, and it can be written as 1 by 4 x square minus x minus 4. I have taken 4 as LCM and 1 by 4 common from these three terms, and by omitting 1 by 4 you will get 4x square minus x minus 4. This is the answer. Second part is under root 2 and 1 over under root 3. Again, let ax square plus bx plus c be the required quadratic polynomial, and we know that again sum of zeros is equal to minus coefficient of x over coefficient of x square, and product of zeros is equal to constant over coefficient of x square. Therefore, sum of zeros is equal to under root 2, and that will be minus b over a, and product of zeros is equal to 1 over under root 3, that will be c over a, and therefore minus b over a is equal to under root 2 and c over a is equal to 1 over under root 3. Again, by put a is equal to 1, you will get minus b over a is equal to under root 2 minus b over 1 is equal to under root 2 minus b is equal to under root 2, and therefore b is equal to minus under root 2. And similarly, c over a is equal to 1 over under root 3, c over 1 is equal to 1 over under root 3, and so c is equal to 1 over under root 3. Therefore, required quadratic polynomial it will be ax square, a is 1, plus bx minus under root 2 x plus c 1 over under root 3, that is x square minus under root 2x plus 1 over under root 3, and by taking under root 3 as LCM you can solve it as x square under root 3 here minus under root 2 into under root 3x plus 1, that is 1 over under root 3 is taken outside, and here is under root 3x square minus under root 6x plus 1, and this can be omitted. That will be under root 3x square minus under root 6x plus 1 is the final answer. You can also leave the brackets in the final answer. This is the answer. Next question is 0 and under root 5. First step is same. Let ax square plus bx plus c be the required quadratic polynomial, and we know that sum and product of zeros are as given. Therefore, sum of zeros is equal to 0, that is minus b over a, and product of zeros is equal to under root 5, that is c over a. Therefore, minus b over a is equal to 0 and c over a is equal to under root 5. Now again we put a is equal to 1 and we get minus b over 1 is equal to 0. That implies minus b is equal to 0, and that implies b is equal to 0, and c over 1 is equal to under root 5. That implies c is equal to under root 5. Therefore, required quadratic polynomial is ax square, that is 1x square, plus bx, b is 0 into x, plus c, that is under root 5. And so we get x square plus 0 into x plus under root 5. It can be also written as x square plus, it is 0, so this term can be omitted, under root 5, and this is the answer. Question 4th is 1 and 1, that is question 4th. So here sum of zeros is equal to 1, that is minus b over a. Product of zeros also 1, that is c over a. That implies minus b over a is equal to 1 and c over a is equal to 1. Now put a is equal to 1. Therefore, minus b over 1 is equal to 1, and that implies b is equal to minus 1, and c over 1 is equal to 1 implies c is equal to 1. Therefore, required quadratic polynomial is ax square, a is 1, plus bx minus 1x plus c, that is 1. That will be x square minus x plus, sorry, here is 1 plus 1, and this is our required polynomial. Question 5th, minus 1 by 4 and 1 by 4. Again, this is a required polynomial, and so sum of zeros is equal to minus 1 by 4, and that is equal to minus b over a, and product of zeros, that is 1 by 4 c over a, and put a is equal to 1, you will get minus b over a is equal to minus 1 by 4, as minus b over 1 is equal to minus 1 by 4 implies b is equal to 1 by 4. Minus signs are cancelled on both sides, and c over a is equal to 1 by 4. That implies c over 1 is equal to 1 by 4, and that implies c is equal to 1 by 4. Therefore, required quadratic polynomial, that is ax square. A is 1 plus bx. B is what? That is 1 by 4 x plus c, that is 1 by 4. Again, if we take LCM on both, LCM on this side, that will be 4x square here, x plus 1, and it can be written as 1 by 4 x square plus x plus 1, and by omitting this constant term we will get 4x square plus x plus 1 as answer. Last question is question number 6, that is 4 and 1. 4 is sum of roots, 1 is product of roots. Therefore, sum of zeros is 4, that is minus b over a, and product of zeros is equal to 1, that is c over a. Therefore, minus b over a is equal to 4 and c over a is equal to 1. Now again we shall put a is equal to 1 and we shall get a minus b over 1 is equal to 4. That implies minus b is equal to 4, and that implies b is equal to minus 4. And on the same way, c over 1 is equal to 1. That implies c is equal to 1. Therefore, required quadratic polynomial is ax square, that is 1 into x square plus bx plus c, that can be written as x square minus 4x plus 1. And this completes the exercise 2.2. Thank you.